Yesterday we started talking about negative exponents, and we said that a negative exponent is anything to a negative power is a reciprocal. So x to the negative first is the same thing as 1 over x. So when you're doing like a 2x to the negative fifth times negative 3 x to the second, you're going to multiply the coefficients, those integer numbers in front first. So you'll do 2 times negative 3. And when you multiply, you add the exponents, and add the exponents. So change this to add the exponents of like bases. So we'll be able to add those exponents. So we'll be able to add negative 5 and 2. So this is kind of what we started talking about yesterday. Remember, you cannot end with a negative exponent in your expression. So you always have to simplify that. You can have negative coefficients, that's fine, but negative exponents are not. So how would I make this the proper way? How would I make this the proper way? Mackenzie? Okay, so this brings me to a point because that is not completely correct, and I want to be able to talk about that, so I'm really glad you said that. So there is a difference between this versus this. Notice with the one with parentheses, the negative 3 is encompassing the whole entire problem, right? So that does get reciprocated like that to make the exponent positive, right? Do you guys see that? Is that exponent of negative 3 actually on the negative 6? No, it's only on the x. The negative 6 technically has an exponent of 1, so should it move? No, and that is a very, very common mistake. So Mackenzie, don't worry about it. Like, I'm glad you brought it up because actually I was going to do a side note of it right after that, even if you did it right. So it is important you guys realize there's a difference between a parenthesis, which means it's encompassing the coefficients in every variable, versus no parentheses, which means each piece is separate, okay? So be very careful with that. It's on the x. It's very tiny thing there. Do you want? I'll make it bigger. Oh, you still probably can't see that. 1 second. That better? Okay. All right. So when you're dividing, you're going to reduce the coefficients. So simplify those coefficients and subtract the exponents. Of like bases. Remember, you cannot subtract if it's an x and a y. It has to be both x's, both y's, both z's, both whatever letter it is. You cannot end with a negative exponent, so just remember that. So Alexis, what goes into both 5 and 10? 10 doesn't go into 5. It has to be small. Smaller than 5. Or it has to be as small as the smallest number or smaller. So what goes in both 5 and 10? What'd you say?
5.
Yeah, so we can divide top and bottom by 5. And that gives us 1 over 2. And then we can subtract our exponents. So that leaves me with x to the negative fifth over 2. Okay, this is tricky for kids. This kind of problem is tricky, so let's see if one of you guys can figure this one out. How do you think you write up the answer to this one? You can't keep negative exponents here. Sarah? So how would I write that then?
X over 2 to the 5th.
It's not 2 to the 5th, not just the 5 gets flipped. What goes with that 5? The x. Okay, so... Okay, so this is not 100% correct. This is often what I see as 2x to the 5th. But why is that not correct? And like I'm telling you, these are normal mistakes, so it's good that you guys are bringing them up. Madison, why is that not correct? You don't have to flip both of them. Is there a negative exponent on 2? No, that has a positive 1, so the one that's going to stay there. Why is that incorrect?
You would have to bring the x to the 5th down so it would be 1 over 2.
So what happens a lot when you lose everything in the numerator, because you're not going to have anything in the numerator anymore, you guys often just make it a problem that doesn't have a denominator anymore. That's a very common mistake. If you move everything to the denominator, those pieces still need to be in the denominator. So if you move everything from the numerator, it just becomes a 1. Okay, so you replace that with a 1, and this becomes 2 times x to the 5th. So do you guys have any questions on that slide there? I'm glad you guys brought up those mistakes because those are normal mistakes and it needs to be addressed. All right, guys. Let's get through some examples here now. Avery, help me out with that first example on that slide. What would you do first? Okay, that's fine. So let's look at it. What are you doing? What do those parentheses mean you're doing? You're multiplying. Do we have any exponents outside of those parentheses? So we don't have the power rule at all here. So we're not going to be multiplying exponents. What do you do when you multiply and they have the same base? When you're multiplying. If it's the product rule, you add the exponents. So this is the product rule, so you're going to add the exponents. And you'll just multiply the coefficients together too. There's no power, so you don't have to worry about that. Typically the power is what you have to do first. So if it's a power to a power, you have to do that first, but we don't have that going on here. So do you think you could do that now that you know this? So what are your coefficients? What are the numbers in front of the variables?
5 and 2.
So what are you going to do with the 5 and the 2?
Add them.
No, be careful. Those aren't exponents, right? So you're going to multiply them. So you'll do 5 times 2, right? So what are you going to do with x to the negative 4th and x to the negative 2nd?
You add those.
What are you adding together?
The negative 4 plus 4.
So negative 4 plus 2, and can we do anything with y to the 3rd? No. So 5 times 2 is 10. Negative 4 plus negative 2 is negative 6. And then y to the 3rd does not change. So this isn't done yet, Avery, because you have a negative exponent. So how do you write up your final answer? So look at each piece individually and see if it has a negative exponent. Okay, Avery? So does the 10 have a negative exponent? No. So is that going to stay in the numerator? Go to the denominator. It will stay in the numerator because it doesn't have a negative exponents. Positive exponents stay. How about x to the negative 6? What will happen with that? It will move down. So it will move to x to the positive 6. The point of the reciprocal is to change the exponent from negative to positive. So if you make the movement from numerator to denominator, or denominator to numerator, depending on where that negative exponent is, that makes the exponent positive, okay? And then how about y to the 3rd, Avery? Okay. Does that make a little bit more sense? Okay. All right, Spencer, help me with the one right next to it. What would you do first? Well, you're not adding everything together, so you have to be careful with that. What are you Okay, good. So this is the product rule. So we say product rule is you add the exponents, not the coefficients. So you multiply negative 3 and 4 because those are coefficients. Then what are you going to do?
You would add the a, so negative first and negative 1.
So add negative 1 plus 3, good. And what would you do with the b's?
You would also add those.
Good. They're being multiplied, so you add. So the product rule says you add the exponents. The coefficients are still being multiplied, okay? But the exponents are being added. So I get negative 12, a to the negative 4th, b to the negative 1st. Okay, we have negative exponents still, Spencer, so this isn't done. So let's look at each piece separately. So negative 12, does that stay or move down? Thank you. It does stay. It does not have a negative exponent. The exponent on it is a positive 1. The coefficient itself is negative, but is the exponent negative? No, we're talking about negative exponents, not negative coefficients, so that will stay. So just because it's a negative coefficient does not mean it moves. It's only if it has that negative exponent on it. Very good. What about a to the negative 4th? And the point of moving it, the point of the reciprocal, is to make that a positive exponent. And how about b to the negative 1st? And I'm not going to put a 1 on it because it's not necessary. You can if you want to. I will not mark that wrong. You want to do the next one, Jenny? Is that what you said? Okay, go ahead and do the next one, Jenny. So what two numbers are you multiplying? Okay, good. And then what are you going to do? Then what would you do? Good, and that combines our bases. So we get negative 6, x to the negative 6th, y to the 2nd. Remember that negative 6 is only on the x. The exponent of negative 6 is only on the x. There's not that exponent on the coefficient negative 6. That one has a 1, so be very careful. So Jenny, what does that change to? And it makes that positive. Very good. And on top is y to the 2nd, because that is positive. Okay, Morgan, help me with that next one. Okay. Good. Good. Yeah, I'll combine all that for you. So, okay, so what do you have to do here? And how will you do that? Yeah, they're in the numerator, so they'll move to the denominator. The 27 does not move. It does not have a negative exponent. It has a positive 1 on it, so it should not move. All right, questions there so far? Let's get a little bit more challenging then. All right. What do you notice is a little bit different about these two examples here? Jenny?
Instead of just multiplying the 2 parentheses.
There's 3. What's another thing that's different about this problem? Alexis? There's a power rule in this one, right? So this one has a power rule. Power rule usually comes before product rule, so you have to do the power rule first here. And what does the power rule tell you to do? What does the power rule tell you to do? Multiply the exponents. Very good. Not the coefficients, the exponents. So we'll do the power rule first, and then we'll do the product rule. And the product rule tells us to add the exponents. So we have to do that product rule one first. So Kelly, help me out with x to the 5th, y to the negative 2nd, to the 2nd power, that first parenthesis there. How would I simplify that?
You multiply 5 times 2 and 2 times 2.
And then I'm going to rewrite the rest of the problem. So the rest of them don't have powers on the outside, so it'll become a little bit easier for us at this point. So we have x to the 10th, y to the negative 4th, And then I'm rewriting everything else. 1 second. 1 second. Let me get it rewritten. Okay, before you answer there, what questions do you guys have so far? Jill, you're holding your face. Are you okay?
Yeah, I'm just so confused because, like, I'll figure it
No, ask. It's okay.
out. No, because, like, I was gone.
Oh, yeah, that I know. It's hard when you haven't been here. But this one has a power on the outside, and do you see these ones don't? So the power rule tells us an exponent to an exponent is multiplication. The reason for that is because you have 5 x's here, and it tells you to list those out twice. That's what that means. So this is 5 x's listed out twice, so that's a 10 total x's, which is 5 times 2, right? Now, it's hard to look at this with negative, so if this was just 2, a positive 2, if we had 2 y's listed out twice, that's 4. 2 times 2 is 4. So then when we get to this here, if you're thinking about the listing out of it, and think about it in terms of positive first, and then we'll look at the negatives. If you have 10 x's, 2 x's, and 3 x's, you're adding those together. Does that make a little bit more sense? So you can kind of visually see it that way. Obviously, that's not completely how it is with this one because they're negative exponents, so that changes things a little bit. Okay? All right, so what are you going to do next, Kelly?
Multiply -2 times -4.
Okay.
And then x. And then multiply. Or you add 10. And -2.
And what else? There's one more. Very good.
And then you add y. And then -4. And -3.
It's not -3. It's, there you go. So -2 times -4 is a positive 8. 10 minus 2 is 8. Minus 3 is 5. -4 plus 3 is -1, right? It should be positive. Did I say positive and write negative? At least I said it right. I mean, one part of that is correct then. Thank you for correcting me before, we keep moving on. Kelly, how do we change this then?
X goes on the bottom.
Be careful, is the exponent positive or negative? It's on top. It's only if it's negative it moves. There you go. All right. Questions there? Okay, Jacqueline, help me out with the next one. What am I going to do?
Add 5 and -1.
Add what?
5 and -1. Oh no, you have to multiply it.
You have to do what first?
With exponents or something.
Yeah, this has a power on it, so we have to do this first. So the -3 will just drop down. Remember, that's a -1 there. So what does -1 to the third mean you're doing there? What does that technically mean, Jacqueline? If it's -1 and there's a 3 on the outside. Because that negative there means -1. So it means list out -1 how many times? So there you go. Okay, then what do you do from there?
Multiply the exponents.
Okay, so what 2 numbers are you multiplying together?
5 and 3.
Very good. And then I'm just going to drop this part down. Okay, so that becomes -3 times -1, a to the 15th, b to the 27th. And then in the other parenthesis, I'm just dropping that down again. All right, Jacqueline, continue from here. What do I do now?
Add 15.
So we'll do a to the 15th plus -11. Good. What else? What else do you still need to do? You're missing one piece there. What about the coefficients? Yep, they're coefficients. They're not exponents. You just multiply them. So we have 3, a to the 4th, b to the 33rd. Do we have to change anything on this one? Are there any negative exponents? No, so that's just my answer. All right. Questions there before we do the back? You only have 2 more slides. Okay, what rule are we applying in this case here? Alex, what rule are we applying here? What are you thinking? If it's not the right name, I don't care. Just tell me what you're thinking. What rule is that? Even if you don't name it the right way but are semi-close, I will be happy. I don't care. What rule is it?
Subtraction.
You are going to subtract the exponents, so which rule is that then? Sarah? Starts with a Q.
You're dividing.
Dividing, so that is the... So the quotient rule tells you to subtract the exponents. All right, Morel. What am I going to subtract in this first one then?
-2 and -3.
How will I subtract it? It's -2.
So pretty much it'd be adding. Yeah. So it'd be
Right.
-5.
It wouldn't be -5.
Well,
Be careful. It's -2 subtracting. What are you subtracting?
another negative.
A -3. So it's -2 minus a -3.
Oh, so it turns into +.
We'll talk about that in a second. But just so you guys are aware, this is not the subtraction sign. This is a -3. This is not the subtraction sign. This is a -3. So you're doing -2. This bar kind of looks like a subtraction sign, right? Minus -3. So use that bar if you want to as thinking it as a subtraction sign. What else are you subtracting, Morel, before we simplify this?
6 and a 4.
And you always do top minus bottom because that puts it in the numerator then. So I have x to the -2 plus 3, y to the -2. So 2 negatives make a positive. So I have x to the first, y to the -2. Okay, Morel, what does that become then?
X to the first power, y to the second.
Yeah, and I'm not going to write the first power. It's not necessary, but if you guys want to, you can. Okay, Jill, help me out with the next one there. So there's coefficients. So first let's look at those coefficients. What are you going to do with the 15 and the 5? Yeah, so 15 divided by 5 is, and that's because, that's because 5 goes into both of them, just so you're aware. So that becomes 3 over 1. Good. What do you have to do next? Okay, so what are you subtracting? So x minus 5. Can you do anything with that y to the 6th? No, there's nothing. So where does it go in this fraction? Does it go in the numerator or denominator? It stays in the denominator because you're not doing anything to it. If you're not doing anything to it, it shouldn't move. So the y to the 6th just stays. Okay, so you get 3x to the -3rd over y to the 6th. Is that simplified, Jill? So what do I still need to do?
You need to put the 3x in the bottom so the 3 can become positive.
So you're moving 3 and x down?
Yeah.
Okay, is that -3 exponent on the 3?
No, it's just an x. So
Yeah, because this has a positive 1, right? So you just have to move that down. So what does your answer become? What's on top?
3 with an exponent of 3. Or do,
3
oh,
doesn't...
No, okay, because it moved up. Okay. And then you have y to the 6
Yep.
bottom, and then you'd have x to the
Also in the denominator, yes. So 3 over x to the 3rd, y to the 6th. And I just put that in alphabetical order. Multiplication is commutative. It's not a huge deal if you did not do that. All right, Kaylin. Help me with the next one there. What goes into both 8 and 12? Bigger. Not that you're wrong. I just don't have much room to work here. 4. You could do 2 and then 2 again. That works too. So you get 2 on top and negative 3 on bottom. Okay, what's the next thing you're going to do? So tell me how you would subtract the exponents on the x. It would be what? It would be negative 6 plus 4, so I'm going to write it as negative 6 minus a negative 4, just so you guys are aware of where that's coming from. Because remember, you're subtracting, this means negative 6, the bar means minus, and this means a negative 4. That negative sign is not the subtraction sign. Okay, next thing, Kaylin.
And then subtract the y, which would be negative 2 plus 3.
Yep, minus negative 3 is plus 3. And what do we do with the z?
You leave it.
You leave it where it's at. There's nothing to do with it, right? So let me rewrite this real quick, and then we can go from there. The negative usually goes on top, so I'm going to pull the negative to the top. So I have x to the negative second, y to the first, z. So I'm not done yet, am I? What do I still have to do, Kaylin?
You have to move the x down because it has a negative exponent.
Good, so that's negative 2yz over 3x squared. The point of the flip or the reciprocal is to make that exponent positive. All right, finally, Hannah, that last one there, help me out with it. Yep, because 6 goes into both of those, so that's negative 8 on top, okay? Good, then with the y's. Good. Good, so we don't have anything in the bottom anymore, do we? So we can erase that then. So I have negative 8, x to the fifth, y to the second, z to the negative first, as you said. So how do you simplify that? Yep, just z or z to the first is fine. Questions there? I think we have 2 more to do, and then I will hand out the EOC that counts and your homework so that you guys can do some problems and I can kind of check where you're at. Yes, sir.
Could the negative sign go for, like, on the other one, go on the 3 instead of the 2?
It can, but it's really not mathematically correct to put it in the denominator, but I would still accept it. I'd still accept it, but that's not really mathematically correct. It usually goes in the numerator. But again, I'd accept it. All right, any other questions there? Okay, let's do the last 2 then. Iris, help me out with that one, on the first one on this page. Yeah, they're both divisible by 5, so we divide top and bottom by 5. So I have negative 4 over 5. Okay, what else do I do? And? The y will stay, and where will the z go? Yep, so we then can move it from there. So what do we get as our final? Well, let me write this up here real quick. Okay, what does that become? Anything to the 0 power is? That's negative 4 times 1, right? Okay, what happens with the y? Goes in the bottom, and what happens with the z? Okay, so we're just left with negative 4, 5yz to the third. Questions on that one? Went through that a little bit quicker. All right, Carly, what about that other one there? The last one. Can we do anything with that 5? Is there anything to simplify it with? Okay, so that stays. Okay. Can I simplify x to the negative 4th? Okay, so that stays for now. What do I do with the y to the negative 7th and the y to the negative 5th? So how would I subtract that? Very good. And then is there anything to move with the z at this point? No, so it's going to stay where it's at if we're not doing any simplification. So let me just do this real quick. So that's negative 7 plus 5, which is negative 2. All right, there's a lot of movement going on here. What's going to happen? The x to the fourth goes to the bottom, making that positive. It still stays with the x. Good. What else do you move? And that becomes y to the positive 2. Very good. What about the 5? What happens with that? Does it have a negative exponent on it? Does that negative 5 go with that 5? No, there's not parentheses around it, so it has a positive 1. So does a positive 1 exponent move? Nope, so that will stay. How about z to the negative 5th? Moves up to make it positive. All right. Good job, guys.